Less than a minute after takeoff, the crew of a newly overhauled Embraer E190 is struggling with their aircraft. All control seems lost and the crew declares an emergency immediately. But now, a wild ride through the skies of Portugal starts, during which the pilots experience frightening moments as their plane rolls and dives as it sees fit. What happened, and did they make it back to the ground in one piece? Find out with me today as we take a look at the horrific flight of Air Astana 1388. Subscribe so you won't miss any future episodes. Now let's get into it. Welcome to airspace. On November 11, 2018, the pilots of Air Astana 1388 readied their Embraer E190 for its first flight in weeks. The plane had spent well over a month at the maintenance facility here in Alverca, Portugal, just next to the capital of Lisbon. But now, after all maintenance work was completed, it was time to fly the plane back to Air Astana's home base back in Almaty, Kazakhstan. Why is a Kazakh plane maintained in Portugal, you ask? Well, mainly for financial reasons. It's costly to have a maintenance organization that does more than just the daily checking and minor fixing of aircraft, therefore many airlines choose to outsource that task to specialized maintenance providers. As the pilots got the plane ready for the flight, several faults popped up, among them a fault in the plane's avionics computer compartment ventilation. They requested to have that fixed, and after all seemed well, they got ready for departure. But just after liftoff, the captain noticed that the flight controls were not responding the way he expected. Seeing that neither him nor his first officer were able to turn the plane properly, they tried to engage the autopilot to see whether it maybe could be able to provide some control, but it would not activate. Now, the plane was climbing into a cloud layer, all while being nearly uncontrollable. Immediately, the crew declared an emergency and stated to air traffic control that they had lost all control over the plane. They could be observed on the radar screens, doing wild turns and flying sharp corners that would seem impossible to fly in a passenger aircraft. When air traffic control asked the crew what the nature of the emergency was and how they could help, the response from the crew was, "The aircraft is completely uncontrollable, we need vectors to the sea for ditching." That means that the pilot intended to bring the plane to the sea to land on water. They did this to protect themselves and the people on the ground. At this point, the crew were able to control the pitch of the plane, but not the roll. The plane kept rolling over to the sides, sending the plane in wild dives that the pilot somehow managed to recover, for now. Incredulous, the air traffic controller asked for confirmation that the pilots wanted to ditch the plane into the ocean, which the crew confirmed while being audibly distressed. Listen here, I'll translate for you.
Roger flight 1388 with ditching for panic. Ditching. Request panic for ditching.
Unreadable, please say again.
1388 requesting heading for ditching.
After she understood, she provided directions to the crew to guide them to the ocean, 40 miles away to the west. However, the pilots could not manage to bring the plane to follow their commands. It kept rolling and diving, seemingly randomly, and the crew flew more or less in circles instead of out towards the sea. At some point, the crew realized what was wrong. It seemed that the ailerons, those are the control surfaces that control the plane's roll, located at the wingtips, were not doing what the pilots commanded them to do, but exactly the opposite, as you can see on this picture taken during the accident flight. With that knowledge, some control over the plane became possible, but it was still very difficult to control. To gain further control, the crew switched the flight control mode to direct, which allowed for a more direct control over the ailerons without computer intervention. Now, after more than an hour, the crew finally managed to fly in a straight line and more or less at a stable altitude. Since the weather was quite bad over northern and western Portugal due to an approaching cold front, they asked air traffic control if the weather was better somewhere else. Actually, being able to see outside would help them greatly, as it would make attitude corrections easier. Air traffic control directed the plane to the east and sent two F-16 fighters to find and guide the plane to safety. With the plane now more or less stable, the pilots tried to formulate a plan together with air traffic control. They needed an airport with good weather, since they would have to land the plane without any help from the autopilot, all while flying with controls that went right every time they steered left and left every time they steered right. Alverca, their departure airport, or even Lisbon were out of the question, since it rained there and the airports were under a cloud cover that started at 1500 feet above the ground already, and the visibility was only 2 kilometers. Air traffic control then suggested the military airport of Beja, located right here. It had quite good weather and 2 long and parallel runways. The crew accepted and the F-16s guided them there. Finally, the pilots had the landing runway in sight, but control remained difficult and the wind at the airport started picking up. The Embraer E190 struggled down the approach path, but in the end the captain was not able to stabilize the plane for a safe landing, ever oscillating left and right of the centerline. So he decided to abort the approach and go around. A brave maneuver in a plane that was hardly controllable. As the crew flew a wide circle back to the airport, the first officer asked to be replaced by the second first officer that was traveling on the flight deck. He had been severely affected by the wild rollercoaster ride and suffered intense nausea and exhaustion. Therefore, the other first officer that was traveling on the flight deck took over. Thankfully, their planned duty day had been quite long, and the flight was planned with not one but two first officers. As he strapped in, the captain got the plane ready for a second approach. But this one failed as well in the last seconds, as the plane was drifting to the left too much to put it down safely on the runway, and the crew went around again. I can only imagine how they must have felt at that time. Nauseated, exhausted, and probably scared, since the approaches did not work out twice. But still, the captain gathered his resolve, flew a wide circle and brought the plane back for one more approach to runway 19 right. It was more stable than the last two, but the plane was still drifting to the left. Eventually, the captain decided to make do with what he had, stopped the approach to runway 19 right and just went for runway 19 left instead. He touched the plane down at the edge of that runway after just over 2 hours of their wild rollercoaster ride. During the rollout, the plane took out 3 runway edge lights, but remained otherwise intact. As the plane came to a stop, the flight crew finally received their first system-related warning since they took off, as if to taunt them: "Flight control, no dispatch." The 3 pilots and their 3 passengers, all mechanics who had assisted in the acceptance of the overhauled airplane, left the aircraft visibly shaken and in emotional distress, but otherwise mostly unharmed. One mechanic had to be treated for a sprained ankle. Thanks to an amazing crew, this event resulted in no fatalities. But how could this have happened? Let's go back a few weeks to October 2nd. On that date, the Embraer E190 arrived in Alverca for its so-called C-check. This is a mandatory aircraft check that has to be done regularly about every 2 years. It is very thorough, and for its purpose, large parts of the aircraft have to be disassembled and reassembled. During that maintenance period of about 3 weeks, many tasks are done around the clock. Parts have to be inspected, cleaned, reinstalled, or replaced. It is also a very good time to implement any so-called service bulletins. These are changes to the aircraft design that the aircraft manufacturer has done since the last check that must now be changed or installed to the aircraft in the hangar. This was also the case for the Embraer of Air Astana. Among the service bulletins to be implemented, there were at least 2 impacting the flight control system. For one, a new support bracket for the flight control cables should be installed. The old one was prone to chafing, and this new one should avoid that. For its installation, the cables connecting the ailerons to the control column in the cockpit had to be disconnected. The technicians knew that these stainless steel cables would be replaced soon by carbon steel cables, as dictated by another service bulletin. Therefore, they disconnected the flight control cables, installed the bracket they needed to install, and created a temporary fix, reconnecting the old stainless steel cables as per the manufacturer's instructions. As they were no qualified flight control mechanics, they found the documentation confusing, but it didn't matter too much for them since the cables would be replaced later by expert mechanics anyway. During that reconnection step, they made a crucial mistake. They connected the cables the wrong way around. Later on, when the flight control mechanics replaced the flight control cables, they just went by how the cables were installed before and connected the new ones the exact way the old ones were connected. Of course, this should have been done exactly by the book, but the technicians apparently found it easier to just replace the old cables the way they had found them to be installed. When the aircraft was then reassembled bit by bit and powered up for the first time, a few days later, it displayed a fault on the ACAS screens. Flight control, no dispatch. That means that the plane is not allowed to fly due to a flight control fault. The autopilot system must have recognized that something is wrong during the self-test, but due to technical limits, could not describe what it was. Troubleshooting began and lasted from October 26th to the accident date, November 11th. Many technicians, experts, and even a technical representative of Embraer, flown in from the Netherlands, were able to detect what was wrong with the flight control systems. In the end, all 4 flight control computers were replaced and the fault cleared. The plane was returned to service, but on the accident date, the fault popped up again. The technicians powered the plane down and up again, completely, 6 times, until the fault finally disappeared. They then released the plane to the pilots, who took it to the skies. But shouldn't the pilots have detected the inverted flight controls as well? Yes, they should have. A flight control check is done before every flight to see whether they are responding correctly. But the pilots didn't realize the wrong wiring either. Why, you might ask? An effect called an action slip may be to blame for that. While pilots do flight control checks every day, they hardly ever fail. So, our basic human mind builds the unconscious expectation that, because the last 1000 flight control checks were uneventful and correct, so it will probably be for today's flight control check. This is of course wrong, and pilots are expected to do their work correctly every single time, but it is an attempt at understanding how something so basic could have fallen between the cracks. After the pilots had finished the flight control check and the pre-departure checks, they took the misconfigured aircraft to the skies. Now, every time the pilots steered left, the plane rolled slightly right first, but then the movement became more erratic. This is due to the fact that the plane's roll is not only achieved with the ailerons, but also with the roll spoilers. These dump some lift on the side of the plane that is supposed to go down in a turn. With the misconfigured ailerons of the accident Embraer, this provided a very weird behavior. Every time the pilot steered left, for example, the plane rolled slightly to the right. But as soon as the control wheel was turned more, the roll spoilers kicked in and did their function as designed, since they were not connected by steel cables but by wires, controlled by computers. So the plane now rolled right, as wrongly commanded by the ailerons, but dumped lift on the left side, leading to a very unexpected aircraft motion. Only when the crew discovered that when they reverted to direct flight control mode and turned the control wheel only slightly, only the ailerons would deflect, not the roll spoilers, became somewhat stable flight possible. Still, it must have been incredibly hard to fly the plane the wrong way around. If you ever want to try how that must have felt, try crossing over your arms and riding a bike. But don't blame me if you fall, because you most certainly will. During its wild ride, the plane suffered loads of up to 5G, well outside its design limits. This image shows the approximate load exceedances suffered by the plane. Everything that is not white is outside limits, and everything that's red suffered more than 150% of its design loads. As you can see, almost every part behind the wing was found outside limits, and the wings were bent out of shape by the shear forces experienced during the wild ride. In the end, the aircraft was deemed to be damaged beyond economic repair and was written off. Also, have a look at the data recorded by the flight data recorder. I know it looks cryptic, but if you take a close look, it will show you how crazy this ride must have been. Look at all the extremes. There are times the aircraft fell from 20,000 feet to almost 5,000 feet in a matter of seconds, gaining speeds well outside its design limits, then pulling 5G and climbing at climb rates of over 17,000 feet per minute. Amazing. To visualize this, the final report included an image from recreated flight data recorder data. At one point, the plane was heading towards the ground, like this. The final report noted that sloppy maintenance work was to blame for the accident, but also that it is amazing that the error was not discovered. There would have been at least 7 moments in time where the cable inversion should have been spotted, but was not. Also, there were inconsistencies in maintenance documentation. One of them was that the flight control works were written down as completed, while the plane was still in a state that did not even allow works on the flight control system. If you want to listen to the full air traffic control conversation with the pilots, I'll leave a link to that in the description. Thank you very much for watching. I hope you liked this week's video. Make sure to subscribe so you won't miss any future episodes. See you in the next one.